This video is going to talk about acceleration. We've got one on describing motion where we talked about like distance, displacement, speed, velocity. This one's going to be acceleration. The next one we're going to talk about is forces. And then our whole next unit, we're going to talk about how force and acceleration are connected. All right. So acceleration. I want you guys to write down what is acceleration and give me an example. All right. I don't care if you're right or wrong. As long as you do it, you'll get points. Acceleration occurs when there is a change in velocity. All right. So when there's a change in velocity. Great. Now I got to remember what velocity is. Awesome. Oh, great. I just tried forgetting all that. No. Well, okay. So velocity, all that is a rate at which an object changes its position over time. So velocity, we talked about with distance, how much distance it gains over time. So acceleration is when this number changes, all right, and when the velocity changes. So when does velocity change? Well, we talked about it's when an object speeds up. It's increasing its speed. It's going faster. It's gaining more distance over time. When it slows down or when it changes direction, that is when acceleration occurs. You might say changing direction. That's weird. That doesn't seem to make sense. Remember, velocity is a vector, and so is acceleration. So the direction matters. The direction of the rate of the change of velocity, that matters. So we got to make sure that we understand that the direction of the rate of change of velocity is going to matter because that's going to affect the direction of the acceleration. Hit the wrong button there. My bad. All right, so many times you hear, so here's some misconceptions. You hear announcers like, I'm a sports guy, I like to, they hear sports. You hear this a lot where it's like, oh, he accelerates to make the play. Or what he's insinuating is that the person is going really fast. All right, like, oh man, he just flew through that hole. He was accelerates through that hole. It goes really fast. Acceleration doesn't necessarily have anything to do with going fast. A person could be moving really fast and not accelerating. All right. Acceleration occurs when an object changes velocity. It's not necessarily when it's going fast. If I'm going on a plane at 550 miles an hour, I'm going fast, but that doesn't mean I'm accelerating because I'm not. My velocity is staying the same. All right. Acceleration only occurs, here's another one, only occurs when an object speeds up. That's wrong again. All right. An object positively accelerates when it speeds up. It's going to increase its velocity in the same direction. But when an object is slowing down, it's called negatively accelerating. It's slowing down. The velocity still changes, but it's slowing down. So the acceleration is actually occurring in the opposite direction of the velocity. All right, the opposite direction. So we call it negative acceleration. The object's moving one way, but the acceleration is going back the other way. All right, so a general rule of thumb, when an object is slowing down, it's going in the opposite direction. So here you have this is kind of going fast. You got the green arrow is the acceleration arrow. The blue arrow is the velocity arrow, because it's a vector. The direction it's going matters. So when it's going faster, they're going in the same direction, but when it's slowing down, the green arrow is going in the opposite direction of the velocity. So when it's speeding up, the velocity arrow and the acceleration arrow are going in the same direction. When it's slowing down, though, the velocity is still going to the right, but the acceleration is going back to the left. Now here the velocity is going left, the acceleration is going back to the right. All right, so because it's negatively acceleration. The object's actually accelerating in the opposite direction because it's slowing down. The velocity is decreasing, all right, in that path. All right, and we're going to talk about that more later as well. All right, so which car is accelerating? I want you to say, which car do you think is accelerating? We'll watch it twice. We got the green, the red, the green, or the blue. Changing its velocity. Which cars? All right, the red car is going at a pretty constant pace. All right, it starts out going faster than both, and then the blue car ends up beating it, and then the green car almost about ends up tying it. All right, so the blue and the green cars are the ones that are actually accelerating. They're changing their velocities. The red car is staying constant. All right, the red car is not accelerating. All right, and so acceleration is calculated. Here's a formula for acceleration. Ugh, gross. It's bad enough to have letters. Now we got triangles. All that triangle means is it's a change in velocity. That triangle just means change. And acceleration units, when we talk about this, so we're actually going to use this formula. So a change in velocity, what that means is we're going to take how fast it's going at the end. We're going to subtract it by how fast it's going at the beginning. And then we're going to divide that by time. Because acceleration is a change in velocity over time. All right, and since velocity is measured in meters per second and time is measured in seconds, our units for accelerations are going to be meters per second, or meters per second. Oop, I forgot to put a 2 there. Meters per second squared. I screwed that up. My bad. All right, so if we looked at these and we said which object is accelerating, we got to look at the velocity. We got to look at the velocity, and we got to say, all right, well, this one is going changing velocity over time. So if our initial velocity is 2, we go 2 is 0. 4 minus 0 is 4. Divided by 1 is 4. 8 minus 0 is 8. Divided by 2 seconds has elapsed is 4. 12 minus 0 is 12. Divided by 3 is 4. The velocity in A is not changing. However, the velocity in B is clearly changing. All right, so B would be the object that is accelerating. All right, and then here's how you calculate that. Once again, we have a change in velocity. We take the final velocity. This is really hard because we always want to put that number we write down first. We want to write that first in the formula. All right, it's really hard to do that. Sorry, I have really terrible handwriting. It says a motorcycle starts at rest. Ooh, I didn't even give you a number there, but I said at rest. Starts at rest. So the initial velocity, when something's at rest, that means it's not moving. So I'm going to write out the variables I know. So if you get a story problem like this, write out the variables you know. My initial velocity is 0. All right, so if my initial velocity is 0, I'm starting at rest. My final velocity, it reaches 50 meters per second, which is probably a little over 100 miles an hour. Like 110 maybe, I don't know. And then do the math. And it takes 10 seconds to get there. How fast is it accelerating? All right. Well, now I'm going to plug these numbers in. So it's really important to get these written down correctly and then know the formula. I'm going to write down how fast it's going at the end. I'm going to write that down first. My final velocity was 50 meters per second. So I'm going to write that here. My initial velocity was 0. I started from rest. And that whole thing took me about 10 seconds to get up to that speed. So I'm going to do 50 minus 0 divided by 10. So I have 50 meters per second divided by 10 seconds. My answer would be 5 meters per second every second. So what these units are telling me is that I'm increasing my speed. It's positive acceleration. It's a positive number. I'm increasing my speed by 5 meters per second every second. All right. So that's what acceleration is telling me. So when you see a number like this, that means I'm increasing my speed by 5 meters per second every second. All right, and then acceleration can be negative also. So if I'm traveling in a car, my initial velocity, that first number I'm going to write down, VI, that first number in the problem is 40 kilometers per hour. So I'm going to write that down. That's my initial velocity. But it's forced to slam on the brakes to avoid hitting another car. The car slows down to 4 kilometers per hour. That's my final velocity. That's how fast it's going at the end. How long? And that took 3 seconds. All right. So my final velocity, that number, I'm going to write in the 4. That's how fast I'm going at the end. We want to write that 40 in right away because that's the first number we have written down. Don't do that. You're writing your second number down. The final velocity goes in there for 4, and the initial velocity is 40. It took 3 seconds. So I'd subtract those two, and I'm going to get a negative number, and that's okay. All right, because acceleration can be negative. We just learned that. Negative 36 divided by 3 equals negative 12. So I decrease my speed. What this means is I decrease my speed by 12 kilometers per hour every second. All right, so negative 12. Now, and you can always double check this. Reread a problem, because if it says the car slows down, right away that should tip that's negative acceleration. Because when something speeds up, it's getting faster, it's positive acceleration, but when something slows down, it's negative acceleration. All right, and then lastly, velocity time graphs are going to be the graphs we use to explain acceleration. All right, so velocity time graphs, unlike speed time graphs, unlike distance time graphs, which we've already worked on, a velocity time graph shows how much the velocity changes over time. Velocity over time, A change in velocity over time is acceleration. All right, so if the slope on a velocity time graph is the acceleration, because velocity, it's the rise over run. We already worked on that with distance time graphs. How much it goes up by how much it goes over. Velocity divided by time, that is by definition acceleration. So the slope, which is this line here, is the acceleration. So if an object has a positive slope, it's going in a positive direction. That's called a positive slope. That means it is positively accelerating. If there's no slope, like right here, that says constant velocity. Another way to say if the slope is positive, the slope is positive, it's positive acceleration. If there's no slope, it's not going up or down, there's no acceleration. If it's negative slope heading, going down, that's a negative slope. On a distance time graph, that means it's going back. But on a speed or velocity time graph, that means it's negatively accelerating. All right, slowing down. All right, so a negative slope means a negative acceleration. That object is slowing down. So this is where it can get a little confusing because distance time graph, these means different things. On a distance time graph, this means it's not moving, whereas here it means it's just not accelerating. It's moving at a constant velocity, it's just not accelerating. This means it's going back to its origin. On a distance time graph here, it means it's slowing down. It's negatively accelerating. So we'll get some practice at that. That'll take a little bit of time, but it shouldn't be anything too tricky. All right, so that's how we are going to be able to describe acceleration through those different ways.